So which is the graph for y equals 1/2 x squared plus 1? So instead of just identifying which one is the graph of this function, we're going to look at each one and write the equation of each function. And certainly we could go ahead and put this in our calculator and match it, but we're going to use what we know about the parent graph y equals x squared to determine what the equation of each of these lines are. So by looking at all of these, they all seem about the same width. So we're going to assume that they have a coefficient with the x squared of 1/2. So this first one here is y equals 1/2 x squared. The 1/2 is positive because the graph falls and then rises. And if we look at the parent graph of y equals x squared, the vertex is at 0, 0. In this graph A, the vertex is at 0, 1. So this graph has been shifted up 1. So we're going to add plus 1 to the x squared. So the first graph is y equals 1/2 x squared plus 1. Let's look at B. Again, we're assuming that the 1/2 x squared will go there for the same width, but this one, in this graph, it rises and then falls. So that's going to be a negative 1/2 x squared. And again, the vertex is at 0, 1, so it appears that it's been shifted up and reflected. So the equation of this line is y equals negative 1/2 x plus 1. Negative 1/2 x squared plus 1. And for C, we have, again, a graph with 1/2 x squared, and it's positive because it falls and then rises. But in this instance, it started at 0, 0 and was shifted down. So the equation of this line would be y equals 1/2 x squared minus 1. In our last example, the graph rises and then falls, so it's a negative 1/2, and again it was shifted down. So the equation of this line would be y equals negative 1/2 x squared minus 1. So today we're going to learn how to solve quadratic equations by graphing. So we're going to be looking for solutions. The solutions to a quadratic equation are called the roots. And the x-intercepts of the equation are called the zeros. The words roots, solutions, zeros, and x-intercepts are synonymous. They can be used interchangeably. They all mean, where does the graph touch the x-axis? What is the x value when y is 0? So we're talking about parabolas, and when we graph parabolas on a coordinate grid, they can touch the x-axis in 3 different ways. First, we can have one with 2 roots. Here's an example. This parabola is touching the x-axis at 2 places. Each place it touches could be called the x-intercept, the zero, the root, or the solution. An example of one root is where the parabola's vertex is on the x-axis. Again, this is called one root. It's a root, a solution, a zero, or the x-intercept. And we can also have the case where there are no roots, where the graph never touches the x-axis. And the solution here would be no real numbers. You'll learn about imaginary numbers in Algebra 2, and you'll learn how to solve solutions for those, but not in this course. So let's solve 0 equals x squared plus 4x plus 3 by graphing. Well, as you can see, the first change yesterday when we were graphing quadratic functions, this was y equals. Since we're solving an equation, we're not going to have the y there, we're going to have the 0, because we want to know what x is when y is 0. So the first thing I'm going to do is identify my axis of symmetry so I know what my x value of my vertex is. So to do that, I identify my A, my B, and my C. So A equals 1, B equals 4, and C equals 3. Now that I've identified these, I can place that into my axis of symmetry formula, x equals negative b times 2a, and solve, and find out that my axis of symmetry is negative 2, which is also the x value of my vertex. So now I'm going to go into my calculator and graph it, and hit trace and put negative 2, enter, and I see my vertex is at negative 2, negative 1. I can also look at my table, and I can see negative 2, negative 1. If I look at my y values, they're decreasing. They get a negative 1, then they start increasing. I also see that this graph has two roots. It appears to be hitting at negative 1 and negative 3. And if I look at my table, I see that negative 3, 0, and negative 1, 0, the x-intercepts, are where the graph is touching. So, if I wanted to write what the roots or zeros are in roster form, I would write a bracket, negative 3, comma, negative 1 bracket. And those are the solutions to this quadratic. In our next example, solve x squared minus 6x is equal to negative 9 by graphing. Well, in order to solve it, we need it equal to 0. So we need to add 9 to both sides. And when I do that, I can rewrite this as x squared minus 6x plus 9 equals 0. Now I can start to solve by graphing. So again, the next thing I'm going to do is identify my A, my B, and my C. A is equal to 1, B is equal to negative 6, and C is equal to 9. I'm then going to substitute it in my formula, x equals negative b divided by 2a, and I find that x is equal to 3. When I graph this one, I see that my vertex is 3, 0, and I see that is hitting the x-axis. So this has one root, or sometimes we call it a double root. And if I look at my table of values, I see that 3, 0 is an x-intercept. And I can also see that the numbers, the y's are decreasing, they get to 0, and then they start increasing. It's also my vertex. So this has one solution. And I could describe that as a bracket with a 3 with a bracket in roster form, just a 3 in there. And next example. Solve x squared plus 2x plus 3 equal to 0 by graphing. Since it's equal to 0, I'm ready to go. So the first thing I'm going to do is find my a, b, and c. A is equal to 1, b is equal to 2, and c is equal to 3. Again, I'm going to substitute it into my axis of symmetry formula. X equals negative b divided by 2a, and I'm going to get a negative 1. When I graph that, I see my vertex is at negative 1 and 2, but it's not touching the x-axis. Let's look at that at the table. So my y values decrease, they hit 2, and then start increasing again. They never touch the x-axis. So this is an example of a quadratic equation that has no real roots. So to describe that, we would just have an empty set. We could have brackets here, braces with nothing in it, or a 0 with a line through it. Next example, solve x squared minus 4x plus 2 equals 0 by graphing. Well, it's equal to 0, so I can start by identifying my a, b, and c. A is equal to 1, b is equal to negative 4, and c is equal to 2. To find my axis of symmetry, I substitute in negative b divided by 2a, and I find out that equals 2. When I graph it, I see my vertex is at 2, negative 2, and when I look at my graph, I see it's not touching at an integer. It's not touching at 1, 2, 3, 4. It's touching somewhere between 0 and 1, and 3 and 4. We describe this as having no integral root. That means the root, the solution, the x-intercept, or the 0, is not an integer. And if I look at my table, I can see I can't see any 0 because my table is listed by integers. So for today, how we're going to describe this is we're going to say that the first 0 falls between, where's this x-intercept? It's between 0 and 1. And our second 0 falls between 3 and 4. Solving quadratics using square roots. So we've done this before, so I'll give you a moment and go ahead and solve these. We'll be taking the square root, and since it's an equation, we need to have a plus or minus in front of our solution.